This is going to be part 2 of the videos about graphing exponential functions. And we were looking at exponential functions which have different kinds of a's and b's. And here I've got another one, y equals 1/2 raised to the x power. Okay, so it's an exponential function. The b, the common ratio, is a fraction. It's between 0 and 1. So let's see what happens with that when we create a table of values and the inputs are -1, 0, and 1. Okay, so 1/2 to the -1 power is the same as saying 1 to the -1 over 2 to the -1. And I could basically turn this into 2 over 1. So -1 to the, 1/2 to the -1 power is going to be 2. What about 0? Well, 1/2 to the 0 power, once again, anything to the 0 power is 1. So this is going to be 1. How about an input of 1? Well, 1/2 to the first power is 1/2. Let's see what that looks like as a graph. Okay, so here I've got a graph. It's my x-axis, my y-axis. I've drawn some tick marks for the scale. And, previously my graphs have all been increasing as you go from left to right. Watch what happens with this. When x is -1, y is 2. So I'm starting up here at 2. When x is 0, well, y is 1. That's my vertical intercept. And when x is 1, y is 1/2. So my graph is going to have a curve that decreases as x gets bigger. Well, this kind of makes sense because, I'm taking this fraction 1/2 and I'm raising it to higher and higher powers. Each time I raise it to a power, the 1 is going to stay the same, but the denominator is going to get bigger and bigger. And as the denominator gets bigger and bigger, the whole fraction becomes smaller. So this is a graph that decreases as I go from low numbers to high numbers. It's going to have the same domain. I can put any number I want in for x, and it's going to have the same range as the kind of graphs we've been seeing before. The range is going to go from just above this x-axis, so the range is going to go from 0 all the way up to infinity, but it's a graph that decreases in value. Okay, so we've looked at situations. Actually, let me just talk about one more thing. What if I make this 3 times 1/2 to the x? All that's going to do is change these values, the y values. They'll be multiplied by 3. So instead of a 2, I'll have a 6. Instead of this 1, I'll have a 3. Instead of 1/2, I'll have 3/2, which means I could just change the scale. I could write a 3 here and a 6 here, and now I've got my graph. So in other words, changing the amount of the a without changing whether it's positive or negative is just going to basically change the scale of the graph. It's going to stretch it up or down, but it's not going to flip it over or anything. Okay, so let's try to generalize this whole thing. I've got this general equation, y equals a times b to the x. And let's see what happens. When a is positive, I've got a graph where all my values are positive. And when b is greater than 1, I've got a graph that increases in value. So in other words, if a is greater than 0 and b is greater than 1, the general shape of my graph is going to be a curve that curves upward as we go from left to right. Okay? As a gets bigger, this curve may become steeper. It may become more exaggerated, like this. But it's going to be the same basic curve. Okay? Now, what happens, let's see what we should change. what happens when a is less than 0? Remember, we were able to have negative numbers there. So all that does is it takes the curve we had before and it flips it over. It flips it across the x-axis so that everything is below the x-axis and the curve sweeps downward as we go from left to right. This is going to keep the same domain from negative infinity to positive infinity. Exponential functions are always going to have the same domain because we can always have anything for x. But it's going to change the range. The range is now from negative infinity up to, but not quite touching, 0. Okay, so what other options do we have? Well, let's go back and make the a value greater than 1. But let's make the b value be some fraction between 0 and 1. So I've got 0 is less than b is less than 1. That's what happened when we did something like b, made b into 1/2. Well, remember when we have a fraction as the ratio, as the b, we get a graph that decreases in value as it goes from left to right. It's still above the x-axis. It still has the same domain, negative infinity to positive infinity. That will always be the case. And it still has the same range, from 0 up to infinity, but it's constantly decreasing. Okay, and the last option would be, what if a is less than 0, a is a negative number, and b is between 0 and 1? Well, all that would do would be to flip this graph, take all the values that we have, and make them negative values. So your graph would now be below the x-axis. It would increase in value. It would have the same domain, negative infinity to positive infinity. But it would never, its range would go from negative infinity up to, but not quite touching, that x-axis, up to but not quite including 0. Okay, so take some time and fiddle around with these. You can take this general idea of y equals a times b to the x, and in a graphing calculator, put in positive a's, put in negative a's, put in b's that are greater than 1, put in b's that are fractions, and see how your graph moves around, just so you get a good intuitive feel for this. Okay, so that's it for now. Take care. I'll see you next time.